Example 101I. For the beam shown below, with constant E, compute the following deflections by the double integration method. So, deflections at A, at D. E is constant. Moment of inertia of the portion AB is twice of I, and for portion BCD, it is just I. So, we establish two equations here. First, let's solve for the reactions. Call this By, Bx is 0, definitely, then R sub C. So summation moment C0 or moment C0. So we have By times 12, then minus 1/2 of 15 times 30 times 2. This is 2 because 1/3 of 15 is 5. So 5 minus 3. So the moment arm is 2. Then minus 40 times 15. 3 plus 12. Solving for By is equal to 87.5 kilonewtons. Then moment at B0, counterclockwise positive, so equals R sub C times 12 plus 40 times 3 minus 1/2 of 15 times 30 times 10, where 10 is 2/3 of 15. So the distance of the force here, equivalent to this area of triangle, is 2/3 of 15 from B, so 10. Solving for R sub C is equal to 177.5 kilonewtons. So we then establish differential equation of the elastic curve for portion AB. E times 2I y double prime, so call that X. And this one for the second part, call that X. So E times 2I y double prime AB is equal to negative 40 times X. So that's the equation because we only apply this for portion AB. Divided by 2, so EI y double prime AB equals negative 20x. Integrate once, EI y prime AB equals negative 10x squared plus C sub 1. There is C sub 1 because A is not a support. There is slope at A. C sub 1 is the slope at A. And C sub 2 also is the deflection at A. So EI YAB is equal to negative 10/3 x cubed plus C sub 1x plus C sub 2. Then we can only establish one condition, that is when x is 3, YAB is 0. But before that, let's call this W. W as to quantity x minus 3. This is x minus 3 for section BCD equals 30 as to 15. So therefore W is 2 times quantity x minus 3, that one. So that the equation EIY double prime BD or BCD is equal to BY 87.5 times x minus 3, this is x minus 3, plus RC 177.5 times x minus 3 plus 12, so this is x minus 15, then minus 40 times x, then minus the moment of this triangular load, which is 1/2 of quantity x minus 3 times W, which is 2 times x minus 3, moment arm x minus 3 divided by 3, or x minus 3 divided by 3. So again, area 1/2 of base x minus 3, height 2 times x minus 3, moment arm quantity x minus 3 over 3, or 1/3 of x minus 3. Simplifying, EI y double prime BD is 87.5 quantity x minus 3 plus 177.5 quantity x minus 15 minus 40x, then quantity x minus 3 cube over 3. Third cancel 2. Integrate once. So we have 43.75 x minus 3 square plus 88.75 quantity x minus 15 square minus 20x square minus quantity x minus 3 to the 4th over 12 plus C sub 1 plus C sub 3 rather, because this is a separate section. Then Integrate EIY BD is equal to 43.75 over 3. That's 175 over 12x minus 3 cube. 88.75 over 3. That's 355 over 12x minus 15 cube. Minus 20 over 3x cube. Then minus x minus 3 to the fifth over 60. Plus c sub 3x plus c sub 4. So there are constants of integration for portion CD. Then boundary condition. 0 equals negative 10 thirds of 3 cube when x is 3, y is 0 into this equation here. So when x is 3, yab is 0. And ybcd or ybd is also 0. So for this equation here, substitute x is 3. So negative 10 thirds 3 cube plus c sub 1 times 3 plus c sub 2. Simplifying, 3 c sub 1 plus c sub 2 equals 90. Call that equation 1. Then when x is 3, ybd is 0 into this equation. So this is 0, this is negative, so ignore. So we begin with this term. This is 0 again. Then c sub 3 times 3 plus c sub 4. So 0 equals negative 20 over 3 times 3 cube. Then 0 plus c sub 3 times 3 plus c sub 4. Simplifying, 3 c sub 3 plus c sub 4 equals 180. Call that equation 2. Then when x is 15 at c, ybd is 0. So 0 equals 175 over 12 cube. This is 0. Then minus 20 over 3, 15 cube. Minus 12 to the fifth over 60. 15 minus 3 is 12. Plus 15 c sub 3 times 15 plus c sub 4. Simplifying this equation, we have 15 c sub 3 plus c sub 4 equals, make this positive, then minus this. So that would be 1447.2. If we solve equations 2 and 3 simultaneously, you can eliminate c sub 4 easily. So we can solve c sub 3 and c sub 4. C sub 3 is 105.6 while c sub 4 is negative 136.88. Then the common point is B. Slope at B, considering AB, is also slope in BD, considering BD. So negative 10 in y prime AB, negative 10 3 square plus c sub 1, the slopes are equal. So take note, theta B is common for AB and for BD. So negative 10 times 3 square when x is 3 plus c sub 1, that's the slope at B, is also the slope at B considering this equation here. So this is 0, negative, so we begin with this term, negative 20 times 3 square. This is 0 again, plus c sub 3. And since c sub 3 is 105.6, so plus 105.6. Substitute, we can solve for c sub 1. C sub 1 is equal to 15.6. Now that we have c sub 1, then in equation 1, we can solve c sub 2. So 3 times 15.6 plus c sub 2 equals 90. So c sub 2 is equal to 43.2. Finally, the interpretation c sub 1 over EI is the slope at A. Then c sub 2 over EI is the deflection at A. So we now have an answer for the slope, theta A, 15.6 over EI, and delta A, 43.2 over EI. Then for the deflection at D, slope and deflection at D, we already have c sub 3 and c sub 4, so we substitute here to solve for the slope at D. At D, x is 18. 3 plus 1 plus 3 is 18. So substitute here. EI theta D is 43.7515 square plus 88.753 square, 18 minus 15, minus 20 times 18 square, then minus 15 to the fourth over 12 plus C sub 3, which is 105.6. So theta D can now be computed. Theta D is 49.35 over EI. Then substitute here to solve. X is 18 to solve for delta D. So EI delta D is 175 over 12 times 15 cube plus 355 over 12 times 3 cube, 18 minus 15, minus 20 over 3 times 18 cube, minus 15 to the fifth over 60, plus 105.6 times 18, plus C sub 4, negative 136.8. So delta D is equal to 245.25 over EI. So that's it for this problem. Anyway, this will be solved by other methods to verify these answers.